So, good evening, everyone. Welcome back to the NPTEL online course for problem clarification and doubt solving. So, today we will start with the contents of week 10. And as you all know, that Dr. Bhanu Prakash is the course instructor for this course on water and wastewater treatment. And I am one of the teaching assistant. My name is Akash Saha, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. So we will quickly see the contents of week 10. So we started with hardness. What's the definition? What are the goals of softening to remove this hardness? What are the different types of carbonate, non-carbonate hardness? Okay, what is alkalinity and what the relationship of alkalinity with hardness? Then we learned about the treatment, starting with the lime soda process. Okay, the various aspects of it, the effects of pH on the precipitation and so on. And then we talked about recarbonation, which is a very important thing after this lime soda treatment. Okay, so decrease the pH. And then some more points about the types of softening basins. Okay, what is split flow lime treatment and what are the various design variables for the basins. Like like that, we covered all these concepts regarding this hardness and its treatment, majorly through lime soda process. So this was all the content about week 10, and now we will solve some problems. So today I think mostly we have numerical problems only, but in between some MCQs are also there. So let's start with them. So the first question says that which of the following is the reason of temporary hardness in water? Carbonates of calcium and magnesium, bicarbonates of calcium and magnesium, nitrates of calcium and magnesium, or sulfates of calcium and magnesium. So what do you think, which of them are the reason for temporary hardness? A and B, D. Okay, so I am getting different answers. So just always remember that temporary hardness is that hardness which you can remove easily by boiling. Okay, so it has to be in a very simpler form, and mostly uh, it is with the carbonates and the bicarbonates. Okay, so when we are talking about the temporary hardness, it's only the carbonates and the bicarbonates, whereas the nitrates, sulfates, or the chlorides, okay, all these things will give the permanent hardness, right? So can you tell me, will calcium and magnesium will only give us hardness, or other uh, cations can also give hardness? Do you know? Like, when do we say that this particular cation will give hardness? What are the different cations? Is it only calcium and magnesium, or other ions are also there?
Sir, every multivalent ions is responsible for hardness.
Yes. So any multivalent cation. Okay. So except this sodium or lithium, these are single valent. So apart from this, if there is ferrous, or should I say ferric, okay, then aluminium Al3 plus. So calcium and magnesium are the most commonly found cations in the treated like water systems. Okay, so that's why we are more concerned about it. But apart from that, any multivalent cation will give hardness. So that's how we define them. Okay, next problem. A water sample contains 120 gram of carbonate, 91.5 gram of bicarbonate, and 51 gram of hydroxyl ions. What is the total alkalinity of the water expressed as CaCO3? Okay, and you have to neglect the effect of H plus ions, right? So can you please calculate quickly and tell me, because I think we have solved similar type of problem. So I'll wait for a minute or so. Or at least calculate to convert one of them into uh, milligram per liter as, or gram in gram as CaCO3. So how do we convert it? Any idea? Any idea how we multiply with molecular weight of CaCO3? Is it the only thing? Does multiplying with molecular weight give us the concentration in terms of CaCO3? And is it molecular weight? Please think about it. Any other answers? To convert the concentration, okay, in terms of ions, if we want to get the concentration in terms of CaCO3, what we have to do? No idea? Okay, before that, that conversion I will solve. Before that, can you tell me why they have told to neglect the H plus ions? Why they have told to neglect the H plus ions? Any idea? Suppose I am giving you the pH as 6. So will it have any effect on the alkalinity? If I am given that with this data, the pH of the system is 6. Okay. So will it affect my alkalinity? Please answer anything, like whatever you feel like. It's not just about solving the problem, that we will do anyway. Okay. But you tell me, like, why should I neglect the H plus ions? Or what role the H plus ion will play while calculating the alkalinity? Any idea? See, yeah, whatever you saying, it is okay. But think in terms of alkalinity. What do you mean by alkalinity? First of all, okay, let's start with the basic thing. What is meant by alkalinity? Is it the acid neutralizing capacity? Yes, that is true. So if H plus ions are there, will it increase my alkalinity or will it decrease my alkalinity? So presence of H plus ions,
Decrease the alkalinity.
so it will decrease my alkalinity. That is true. So that's why when we are calculating the alkalinity, we will add the carbonate, the bicarbonate, and the hydroxyl ion concentration, and then subtract the H plus ion concentration. So that is the formula for alkalinity. Okay, so it will be in terms of summation of all these alkalinity producing ions like carbonate, bicarbonate, and OH minus, and then subtract the H plus ion concentration. So in this question, they are saying that okay, there is no H plus ions, so you can neglect it. Because if we are considering the H plus ions also, if we are considering the pH of the system also, then the alkalinity will be reduced. Very minutely maybe, but it will be in a decreased form. So that's why we have to neglect it. Okay, now the next question is, okay, repeat the concept. So I was telling, you are able to hear me, right, Amit? Now, are you able to hear me? Yeah. So I was saying that alkalinity is the acid neutralizing capacity. Okay, so acid neutralizing capacity means whatever is the concentration of these carbonates, bicarbonates, or hydroxyl, which can neutralize the acid, I will calculate that concentration. Okay, so we will add all these things. Now, if some hydro, these H plus ions are there, if this H plus ions are there, this will decrease my acid neutralizing capacity. Okay, so that's why at the end we have to subtract the H plus ions concentration. So that is the funda here. And in these questions, this pH is not known. So we don't know the concentration of H plus ions. If we know the pH, we can calculate the H plus ion concentration. So that's why they are telling to neglect the H plus ion concentration. Because if it is present, then it will decrease my alkalinity. Right? So now when we want to calculate the alkalinity, we cannot simply add the concentrations of all these things because these are in terms of that particular ion. Okay, so normal addition won't be proper. So that's why we convert everything in terms of milligram per liter or milligram of CaCO3. Okay, so we will convert everything to in terms of CaCO3, then we will add it. So that means we will adding a common base. So that is the main logic behind converting these ionic concentrations into the concentration as per CaCO3. Okay, right? So I will solve this. So in this question number 2, I have first 120 grams of CO3 2 minus. CO3 2 minus, that is a carbonate. So whenever some concentration or some amount is given in terms of that specific ion, first we will divide it with its equivalent weight. So what is the equivalent weight of carbonate? It is 30. Okay. So what we will do? We will do 120 by 30, which is equal to 4. So it will be 4 gram equivalent. So it will be 4 gram equivalent. Okay. So the molecular weight of carbonate is what? 12 plus 3 into 16. So that means 60. And the equivalent weight will be 60 by 2 because the carrying capacity is 2. So it will be 30. So that's why I divided with 30. So it will be 4 gram equivalent. Now I have to convert into as per CaCO3. So what I will do? We will multiply this 4 gram equivalent into the equivalent weight. Into the equivalent weight of into the equivalent weight of CaCO3. So I will just multiply it with 50. So the total molecular weight of CaCO3 is 100. So 100 by 2, again it will become 50. So unto 50 gram of CaCO3. So it will be around 200 gram of CaCO3. Okay, so very simple. First divide by with its own uh, equivalent weight and then multiply with the equivalent weight of calcium carbonate, not with the molecular weight. So always remember. Now next we have 91.5 gram of CaOH, HCO3 minus. So it will be 91.5 divided by HCO3 minus the molecular weight is 61. Equivalent weight will also be 61 because minus 1. Okay, so 61. So that's why it is 1.5 gram equivalents. Then 1.5 into 50 gram of CaCO3. Now it will become as 75 gram of CaCO3. Now the last one, 51 gram of OH minus. So now tell me what is the equivalent, what is the gram in terms of CaCO3? Please calculate and tell me. Quickly you can do it. Very simple. Just tell me what will be the answer. If I have 51 gram of OH minus. So what will the first step? First will be 51 divided by what? 17. Yes. Right. 17. So it will be 3 gram equivalent. If it is 3 gram equivalent, then what is the gram as per CaCO3? What will be the answer? So 3 into 50, that means 150 gram of CaCO2. Okay, so total alkalinity, that's what we have to calculate. So that will be total alkalinity will be 200 plus 75 plus 150. That will be equal to 425 gram of CaCO. So this is the answer. Okay. Now suppose if we have the pH of the system is known. Suppose pH of the system is known. So that means pH, if I say 6. So what will be my H plus ion concentration? Because pH is minus log of H plus will be 6. So from here I will get H plus ion concentration. So that H plus ion concentration I will convert into milligram as CaCO3 or milligram per liter as CaCO3, and then I will subtract it from here. If I subtract it from the total, I will get the total alkalinity because it will decrease my alkalinity. It will decrease my acid carrying capacity. So that's how we have to do. Is it clear? I hope it is fine. Right? Okay, we will go to the next problem. So same thing is written here, 425. Okay, match the type of impurity with its effect in water and select the correct answer using the codes given below in the list. So we have carbonates and bicarbonates of calcium and magnesium, carbonates and bicarbonates of sodium, sulfates and chlorides of calcium and magnesium, oxides of iron and magnesium, manganese. So what effects do they have? Permanent hardness, temporary hardness, alkalinity, color and taste. C. So you are getting C. So when we talk about the carbonates and bicarbonates of calcium and magnesium, so always remember calcium and magnesium will give us hardness and carbonates and bicarbonates will give us temporary hardness. Okay. So A is 2. Then carbonates and bicarbonates of sodium. Okay. So before that, sulfates and chlorides of calcium and magnesium. So sulfates, so calcium and magnesium again will give us hardness, and sulfates and chlorides will give us permanent hardness. Okay. So C is 1. Then the next one is carbonates and bicarbonates of sodium. So, okay. Just a minute. I am getting one call. I'll just come back. Yes, sorry for the small break. So, as I was telling, that sulfates and chlorides will give the permanent hardness, and then the oxides of iron and manganese will give order, color, and taste, and then the carbonates and bicarbonates definitely it will give the alkalinity. Okay, so these things will be arranged in this particular manner, and we will get. Oh, Amit, okay, you are saying something. Okay. Yes, Amit, bicarbonates will give us temporary hardness only. What is the issue here? Because it dissociates further in the reaction, because reaction is in equilibrium. Okay. What is your problem here? Because, yeah, bicarbonates will give us the temporary hardness, whereas chlorides and all, uh, this will form a little, what to say, a stronger bond. Okay, so it will not dissociate very easily just by boiling and all. So that's why they are giving us permanent hardness. So temporary means easily dissociable. So on that aspect only we can define. Yeah. Yes. You can, whatever is your question, you can mail me. Okay. Yeah, yeah, yeah. You can mail me. I think you are getting confused between permanent and temporary. Okay, so carbonates and bicarbonates will only give us temporary hardness, and the rest of the things like chlorides, sulfates, or nitrates will give us permanent hardness. So that is the thing. Okay, next question. It says that in a wastewater treatment plant situated in a city, sewage water from numerous households is treated. The influent water has a pH of 6. After treatment, the effluent has a hydroxyl ion concentration twice the influent wastewater. Determine the pOH of the effluent. Okay, so it's simple. Hydroxyl and H plus ion concentration we have to talk about here based on the pH and the pOH. Okay, so it says that there is a sewage treatment plant where sewage is coming and the influent pH is 6. Okay, and the effluent has whatever hydroxyl concentration was there in the influent, the effluent has the double amount of hydroxyl ions. Okay, so you have to determine the pOH of the effluent, not the influent but the effluent. So just calculate. Do you, if you want any suggestions, you can ask me now. Try solving the question. It's a pretty straightforward question. Just the basic concept of pH and pOH. And just now I told you how to get the hydroxyl ion concentration from the pH. So the same thing applies for pOH. And for these type of questions, you please uh, practice using the log in the calculators. Okay, logarithm, anti-logarithm, all those things you please try to calculate so that you can solve these problems. Otherwise, it will be a difficult task in the examination. Okay, if you are not familiar, if you are familiar, then it's fine. If you are not familiar with calculating log of any number in calculators, okay, then please practice those things in the digital calculator or the online calculator. Okay, we'll see how to solve this problem. I think you may have some doubt. Okay, so question number 4. So it says that uh, pH of the system is given. pH of the influent is given as 6, right? So we all know what is pH plus pOH. What is the value of pH plus pOH? Total of the water system?
14.
14, yeah. Okay, so here we can put, so 6 plus pOH is equal to 14. So the pOH of my influent, I will say, pH of my influent will be 8, right? So if I know the pH, I can calculate the OH minus concentration because pH is nothing but minus log of OH minus ions. So that is 8. So my OH minus concentration will be equal to 10 to the power minus 8 moles per liter. Now it is saying that pOH of the effluent is nothing but 2 into pOH of the influent. So this is given in the question. So this is nothing but 2 into 10 to the power minus 8 moles per liter. Okay. So therefore, the pOH can be minus log of 2 into 10 to the power minus 8. So that will, if I solve this in calculator, I will get 7.69897. So we can see that pOH initially was around 8. Then after the sewage, after mixing with the CH, it dropped to 7.69897. Okay. So that's what is happening, right? Okay, one question I want to ask. Can the pH of any chemical or anything, can it be greater than 14?
No, sir.
Why? Why do you think so? Why do you think so? Any idea? Just think about it. Or let's say pH less than 0. Is it possible?
Not possible, sir.
No, but what is the reason? Any idea what is the reason that pH cannot be more than 14?
Sorry, no idea about it.
No idea. Okay. See, whenever we are saying that this pH plus pOH is equal to 14, okay, this is mainly, I will say it for aqueous conditions. Okay, aqueous conditions, it is in solution form or something. Okay, it can be in solution form or something. Suppose, what is like pH? We define it as negative log of H plus ions. Okay, or let's say pOH, it is negative log of OH minus ions. If I keep on increasing, suppose I am taking NaOH, okay, and I am saying it's a 3 molar solution. It's a 3 molar solution. Okay, so now what will be my pOH? So my pOH will be nothing but minus negative mole of what is the thing that is, oh sorry, 3. It will be 3 moles per liter. So pH is equal to minus log of 3. Now if I keep on increasing this thing, OH minus, okay, then at some point I can get a pH or pOH more than even 14 or pH less than even 1, but at that time the system may not be aqueous. So what I mean by saying a 3 molar solution is that I have 3 moles of NaOH in 1 liter of water, right? 3 moles of. So 3 moles of NaOH means roughly 3 into 40 grams of NaOH in 1 liter. Now to get a pH or pH more than 14, I will have to increase this amount. I will have to increase this amount. So if I am adding in my beaker, if in my beaker water is there, if I am putting more and more salt, okay, if I am putting more and more and salt, the strength of this NaOH will increase, maybe 3 mole, then 13 mole, then 30 mole. Okay, if I'm adding too much of salt in the system, okay, though theoretically we will be getting a pH or pH more than 14, but practically it won't be an aqueous solution that time. Are you able to understand? So theoretically it is possible that we can get a pH more than 14 or less than 1, but practically it won't be feasible, or practically it won't be an aqueous solution, so that the pH plus pH of 14 that we take into consideration won't hold true that time. So just this is something I am deviating from the topic, but something to think about. Are you able to understand anything what I am saying?
Sir, but beyond saturation, it won't dissolve, no? It won't be an aqueous
That's why I am
solution.
saying that it won't be an aqueous solution. It won't dissolve. It will not be a practically possible thing, but I am saying that theoretically it is possible, not in practicality.
Understood.
Yeah,
Yes, sir. Okay.
yeah. Okay, let's not. Okay, the next question. At pH 7.2, the predominant species of carbonic acid in water is bicarbonate ion. Is it true or false? This is very generic.
True.
Any other answer? So, what are the various forms of carbonic acid? So, we have the carbonic acid, we have the bicarbonate, and the carbonate. Okay, so the pH will be least for the carbonic acid, then in the mid range it's bicarbonate, and then carbonates. Okay, so this statement is true. Okay, the next question now. So this is the common data for the next three problems because we need this data to solve the like question number 6, 7, 8. So please note it down and then we will solve. So we have a groundwater sample where the pH is 8.1, and then we have the calcium, magnesium, Na plus, HCO3 minus, SO4 2 minus, and chloride concentrations. Okay, so everything is given here. So So the first question says that what is the total hardness? So can someone tell me how to approach this problem? Any idea how to approach this problem? So what is the first thing we need to do here? So if the problems come, because this is a very frequently asked question in the examination. So I think in your final exam also definitely one question will be of this sort. Okay, so what is the first step do we have to do here? Because they can ask you hardness, alkalinity, amount of lime soda ash required, anything based on these problems. So what is the first step that we will do here? Any idea? No one? So here you can see that only the ion concentrations are given. Okay. And as I have told you before, whenever we are solving a problem related to hardness or alkalinity, to bring everything to the same base, we will convert each concentration into milligram per liter as CaCO3. So that is the most important step that we have to do in every problem, irrespective of whatever is asked. Okay, hardness, bicarbonate hardness, non-carbonate hardness, okay, alkalinity or lime soda ash requirement, anything related to softening, water softening process, we will first convert into in terms of milligram per liter of SCO3. Okay, so first we will make that table and then we will see what is asked in the question. So this is for the next 6, 7 and 8th question. Okay, so first we have the ions. So we have Ca2 plus, we have Mg2 plus, we have Na plus, we have HCO3 minus, we have SO4 2 minus and the Cl minus. Okay, so these are the things given. Now the ionic concentration is given. Ionic concentration is given. So it is 125 milligram per liter, then 30, 23, 240, 55, and then 130. So first we should know all the equivalent weights. So it's better to memorize for all these things so that don't have to calculate again and again. So for calcium it's 20, magnesium 12, sodium is 23, SCO3 minus is 61, then 48 and 35.5. So these three you please memorize because this will be required subsequently in all the problems, whatever we are solving today and whatever will be asked in the examination. So everything is there. Then we will calculate what is milli equivalent per liter. Okay, we will calculate in terms of milli equivalent or equivalents. So you just have to do whatever concentration is given divide by the equivalent weight. So you'll get it as 6.25. Again, whatever concentration is given divided by the equivalent weight. So you'll get as 2.5. So like that we will do for everything. So I'm just writing the answers. Okay, so this table is very important. And then at last, milligram per liter as CaCO3. So what we have to do, whatever we got in milliequivalents per liter into 50, because the equivalent weight of CaCO3 is 50. So as we did in the first problem, so that thing into 50. So we'll get the answer as 312.5. So like that, 2.5 into 50, so we'll get it as 125. So 1 into 50, 50, 196.7, 57.3, and 183.1. Okay, so shall we do the summation here? What will this summation will give us? Any idea? If I add all these things, what it will give? Have you heard anything? That if I add all this concentration in terms of milligram plus CaCO3, what will it give me? Any parameter?
Total hardness.
Total hardness. So how do we define hardness? I think we discussed in the first question, but many of you were not there. So will it give total hardness? So actually that is the first question. So the first question says what is the total hardness? So can someone tell me what is the total hardness? Everything is there calculated. Tell me what is the total hardness. Actually someone answered also in the first problem. What is hardness? Can you answer? What is the hardness? How do we define hardness? You have already told me. How can we calculate the total hardness? So hardness is nothing but the total concentration of multivalent cations. Total concentration of the multivalent cations. So what are the multivalent cations here? What are the multivalent cations here? We have these many ions: calcium, magnesium, sodium, bicarbonate, sulfate, and chloride. What are the multivalent cations?
Sir, Ca plus 2 and Mg plus 2 and sulfate 2 minus.
I am saying only the cations.
Oh,
Sodium.
sorry. Uh, Only calcium and magnesium.
Yeah, so only calcium and magnesium. Sodium is a single valent cation,
Yeah, single
monovalent,
valent ion, not multiple.
monovalent, monovalent cation. It is
Yeah,
a cation, but it is monovalent. And sulfate, it is a multivalent, but it is anion, not a cation.
anion. Yes,
So
yes,
for
yes.
total hardness, we will only see the concentration of Ca2 plus Mg2 plus.
Sir, I have a doubt.
Yeah.
Sir, how to calculate concentration of any cations or anions?
So this is what we have to do. Huh. See, cations and anion, what you are telling, asking about this. This
Not
is
this.
some,
Suppose I have a sample. I want to calculate the concentration of cations like Ca plus
okay,
and magnesium plus 2 plus, I think.
okay,
So
okay.
how to calculate any
See,
formula?
okay, so these you are talking about samples, like actual
Yes,
ground
yes,
samples or lab samples. So we have many
yes.
methods. First is the titration. By titration we can do. So these hardness like calcium and magnesium we can all just by doing hardness. I think it is with the help of this EBT indicator. Okay,
Yeah,
EBT
I
indicator is,
already I do titration method only calculate total hardness alkalinity also.
yeah. So that will give total hardness, and then there is uh, one more. I think it is called murexide.
I
Murexide,
know, I know.
yeah,
Yes, yes.
murexide. So that will give you the calcium hardness. Okay, so that will give
And
you,
I have a formula. Suppose total hardness is 100,
okay.
then 100 into zero point 0.6, that is calcium ions, and total hardness minus calcium ions, that is magnesium ions.
So see, this is you are going come some kind of thumb rule. Okay, so this may not be
Yes,
true
yes,
always. So this
yes.
murexide test you have to do. Okay, so this will give you the properly the Ca2 plus ions. Apart from this, there is a system called as ion chromatograph.
Okay, sir. Okay. Thank you.
Chromatograph or ion chromatography. So this procedure, okay, so ion chromatography, with this procedure you can calculate all kinds of cations and anions. Okay, so it's a very sophisticated technique, sophisticated instrument, ion chromatograph. Okay, IC, we will say it in the normal terms, ion chromatography. Or there are many kinds of other, like for heavy metals. These are also cations. Okay, some heavy metals. So for that, we will use AAS technique. So AAS is atomic absorption spectroscopy. Or we have another instrument called as ICP-OES. Okay, so some plasma techniques. So there are various kind of sophisticated instruments which will help you calculate all these cation and anions. Okay, but this will be in terms of that particular ion. So mg per liter of that particular ion. So these values you are seeing 120, 30. Okay, so these are those values which we get from from these kind of sophisticated instruments or with the help of titration, right? But then once we get this concentration, we will convert everything in terms of mg per liter as CaCO3 and then calculate the hardness, alkalinity, everything. Okay, okay. So coming back to the question, so whatever total hardness, we will calculate the total concentration of multivalent cations. Just that, forget everything, multivalent cations. Suppose in the system Fe3 plus is also there. Will it give hardness? Yes, it will also give hardness. So we have to add Fe3 plus also. Okay, but in my system now it is not there, so I have removed it. So it is not given. So this is the total hardness. Now the next question, question number 8 is what is what is the question number 7 is what is the non-carbonate hardness? Okay, non-carbonate hardness. So see from here, can you tell me what is the non-carbonate hardness? Any idea how to calculate it? How to calculate the non-carbonate hardness?
Sir, that is 196.7.
That is 196.7.
Yeah,
Is it?
bicarbonate is
So
non-carbonate hardness. Oh,
it
sorry,
is.
sorry.
You are
Non-carbonate
telling
total hardness.
carbonate hardness. You are not saying,
Oh, oh, wrong, wrong. Yes, yes.
right.
Sorry, sorry.
So can we directly calculate non-carbonate hardness? No, we cannot directly
Non-permanent is
calculate.
total
Yeah,
permanent hardness, na?
yeah. So
Yeah, yeah.
non-carbonate hardness is the permanent hardness. So to calculate the non-carbonate hardness, first we should know what is the carbonate hardness. Okay, and to know what is the carbonate hardness, we should know the alkalinity. Okay, so many things are coming into picture. So let me explain it to you clearly. So always for these type of questions, it's always better to make a line chart. Okay, line chart. How to make a line chart? Suppose this is my zero level. Okay, now I will make one bar. Okay, so this is my calcium 2 plus. I will make another bar. This is my magnesium 2 plus. Okay, so this is my total hardness. So from 0, so this was 0. So 0 to calcium, what is the calcium hardness? Calcium hardness is 312.5. So I will write it as 312.5. Okay, so 0 to 312.5 is calcium hardness. Then what is my magnesium hardness? Magnesium hardness is around 125. So the next thing will be 312.5 plus 125. So it will be 0.5. So 734. So 437.5. Right? So that was actually the total hardness, 437.5 milligram per liter as CaCO3. Okay. So this is my total hardness. Now this calcium 2 plus and magnesium 2 plus will now combine with CO3 2 minus if it is present, SCO3 2 minus, SCO3 minus, and then it can combine with sulfate, chloride, or some nitrate. Okay. So now if my calcium and magnesium is combining with carbonate or bicarbonate, I will call it as carbonate hardness or temporary hardness. Okay. If my calcium and magnesium is combining with sulfates, chlorides, or nitrates, something like that, I will call it as non-carbonate hardness. So that is my permanent hardness. Is it clear up to here? Right? So these are my permanent hardness. So now in this chart below we will show these ions. So first, always we will start with the carbonate or the bicarbonates. So here I don't have any carbonate or carbonates. I have the bicarbonates. So see, bicarbonate is 196.7. Okay, 196.7. So calcium was up to 312. Yes, permanent hardness can be removed. That's why we will go for this lime and soda treatment. That's how we will remove the permanent hardness. Okay, we'll come back to that. We'll see how to remove all these things. Okay, so where was I? I was saying my carbonate is 196.7. So here I showed all the hardness. Here I will show all kinds of anions. So here I showed the cations. Now here I will show the anions. So 196.5. So somewhat like this. So HCO3 minus, that is 196.5. Okay. Then what else we have? We have chlorides, we have sulfates. So suppose I will adding the chlorides. So some part will be some chloride. Okay. And then, so chlorides is how much? Let me calculate. So chlorides. So 196.5 plus chlorides is 183.1. So 183.1. I am getting 379.6. So it will be somewhere around here, 379.6, and plus the sulfates. So sulfates is around 57.3. So plus 57.3. So I will getting. So so I'm just giving it almost little less than the total. So 436.9. So So are you able to understand what I did here? So in the top, I showed all the cations, and in the bottom, I added and showed all the anions. Okay. So that's how we will represent this kind of diagram. Okay. So now tell me, what is the alkalinity? So what is the total alkalinity here? Just see this diagram and tell me, what is the total alkalinity here? So just remember how we define alkalinity. Alkalinity is nothing but the summation of hydroxyl plus carbonate and bicarbonate ions concentration, right? So what is the total alkalinity here?
Sir, we add total carbonate in milligram bicarbonate and
Hydroxyl.
I think uh, only here bicarbonate, na?
Only bicarbonate is there. So what will be my alkalinity?
Uh,
So what will be my alkalinity?
so the chart, sir. So the chart,
196.5.
yeah,
So
yeah, 196.7.
196. So my total alkalinity is 196.5. Right. You understood? So it is 196.5. Now you just think, so here my total alkalinity 196.5 is less than what? Is less than my total hardness. So it is 196.3. And what is the other one? The other one is 437.5. So it is said that whenever the total alkalinity is less than total hardness, we can say the carbonate hardness is equal to the alkalinity. Do you agree? Can you say whenever my total alkalinity is less than total hardness, my carbonate hardness is equal to alkalinity? Now we will come back to this diagram again. Okay. Now see this diagram and tell me what will be the carbonate hardness. See, carbonate hardness means whenever my multivalent cation like Ca2 plus or Mg2 plus will combine with carbonate or bicarbonate, it is called as carbonate hardness. Okay. So in this system, what is the amount of carbonate hardness? Can you tell me?
196.5.
196.5, because we only have 196.5, and totally this region will be my carbonate hardness. So I can select it. So this region is my carbonate hardness. So we can very well say that whenever my alkalinity is less than the total hardness, the carbonate hardness will be equal to the alkalinity. Okay, so that means carbonate hardness is equal to 196.5 milligram per liter. So what will be my non-carbonate hardness? So
Sir, we add the total ions of calcium and magnesium.
okay, that is the total hardness, right? I am asking only non-carbonate hardness. Whatever you said is the total hardness. How will you get the non-carbonate hardness? So we know the total hardness minus the carbonate hardness will give the non-carbonate hardness, right? So it will be 437.5 minus 196.5. So that is equal to 240.
241.
Okay. So that's how you have to do. Or else what you can do, here. So this red area is carbonate hardness. What about this area? This area is the non-carbonate hardness, right? Because 437.5 is the total hardness. This much red area is the carbonate hardness. So remaining part will be non-carbonate hardness. So simply 437.5 minus 196.5 will give me the non-carbonate hardness. So that's how you have to do. Is there any doubts or any confusion for anyone? You can ask me now, because all the next problems will be based on this particular diagram only. Okay. Every question we have to make this diagram and then solve. Otherwise, it will be a very difficult task. And we will also see how the treatment, as Amit asked me, like how to remove the permanent hardness. So we will see how to add lime and soda ash to remove the permanent hardness also. But this figure is very important. Okay, so always remember, if my total alkalinity is less than the total hardness, we can very well say that the carbonate hardness will be equal to the alkalinity. And once we know the carbonate hardness, we can subtract it from the total hardness to get the non-carbonate hardness. Okay, so this was one part. And okay, then we will solve a similar problem. Let's see if you have understood. Okay, we will solve a similar problem. So I will write it here only. This is actually question number 17. So I will give you all the parameters, you then calculate. So ions we have. So again we have calcium, magnesium, Na, SCO3 minus, SO4 2 minus, and Cl minus. And then ion concentration of those are 100, 6, 15, 250, 45, and 39. Okay, so here you have to tell me what is the total hardness and what is the non-carbonate hardness. Please solve and tell me. I'll wait for some time. First tell me the total hardness and then we'll move forward. I'll wait for you guys for some time. Because it's very important to know that we are doing it correctly. So what is the first step here? So what is the first step here that we have to do?
Sir, total hardness is 275.
Yes, it's absolutely correct. Total hardness is 2. So how you got it? So simply concentrations we know. So equivalent weight we will calculate. So simply we will do, and then we will calculate. I will just directly mark it as milligram per liter as CaCO3. No need to go for two steps. So it will be 100. Okay, 100 by 20 into 50. So it will be around 250, and then again 6 by how much? It is
12, 12,
12 into 50. So we'll get it as 25. So
25.
total hardness will be calcium plus magnesium. So 250 plus 25, it will be 275. Okay. Then for non-carbonate hardness, it is very much required to calculate the alkalinity. For alkalinity, we need to know the bicarbonate only. So it will be 250 by how much? So 250 by 61 into 50 it will come. Okay, so it will be around 204.92. I'm just telling. So 204.92. So now I told you alkalinity is equal to 204.92, and we know temporary hardness is equal to 275. So what can we say? From this data, what can we say?
Carbonate hardness is equal to alkalinity.
Yeah, so we can say directly that carbonate hardness is equal to alkalinity. So that means carbonate hardness is equal to 294.92. So my non-carbonate hardness will be 275 minus 204.92. that is roughly around 70 milligram per liter. Okay, so that's how you have to do it. That's how you have to do it. Okay, now another problem is there, but before that, we will see some more concepts. Okay, we will see some more concepts. So, as we know that to treat this carbonate and bicarbonate hardness, okay, or the permanent hardness, we will use the lime soda process. Okay, so you will see many problems where they are asking that they will give the set of ions, like similarly like how we have seen here, Ca2 plus Mg2 plus all those things. They will give these ions, they will give the concentration, and they will ask you how much lime or and soda ash will be required to remove this hardness. So for that, we need to know some stoichiometries. Okay, we need to know some stoichiometries. So just I will give you the stoichiometric coefficients, and then we will see how we are getting these stoichiometric coefficients. So first I will just give you the data, then we will decide. So we generally in all of the questions we have calcium carbonate hardness, we have calcium non-carbonate hardness, we have magnesium carbonate hardness, or we have magnesium non-carbonate hardness. Okay, and some kind of lime and soda is also required for CO2. Okay, because this can also because for recarbonation or something, sorry, for removing CO2 also we will need some lime and soda ash. So for that also we will calculate the stoichiometry. Now for first I will give lime and then I will give soda ash. So I am just giving you the coefficients. Though the coefficients are 1, 0, 0, 1, 2, 0, 1, 1, 1, 0. So now you must be getting confused like what are these numbers? Okay. So these numbers mean that to treat 1 mole of calcium carbonate hardness, we need 1 mole of lime. To treat 1 mole of calcium non-carbonate hardness, we need 1 mole of soda ash. To treat 1 mole of magnesium carbonate hardness, we need 2 moles of lime. To treat 1 mole of magnesium non-carbonate hardness, we need 1 mole of lime and 1 mole of soda ash. So this is what it means. How it is coming, I will show you. So suppose calcium carbonate hardness means calcium bicarbonate, let's say. So calcium bicarbonate is some kind of calcium carbonate hardness. If I add CaH to it, this is nothing but hydrated form of lime. I will get 2CaCO3 plus H2. So we can see this calcium carbonate hardness is getting precipitated as calcium carbonate. So for 1 mole of calcium carbonate hardness, we need 1 mole of lime. So that's what is mentioned here. Right? Then coming to magnesium carbonate hardness, so MgOH twice. So we will add 1 minute. Yeah. So we need, first we will add 1 lime. We will get MgCO3 plus CaCO3 plus water. Okay. So here we can see to get 1 mole of magnesium carbonate hardness, we need 1 mole of lime to precipitate the CaCO3. So is it matching with our coefficient? Is it matching with our coefficient for magnesium carbonate hardness? No, right? So what is the problem here? Can someone identify what is the problem here? So the problem here is in the case of calcium hardness, calcium non-carbonate, calcium carbonate hardness, everything is getting precipitated as CaCO3. Okay, it is getting precipitated and removed from the system. So you are saying that we have treated calcium carbonate hardness. But in the case of magnesium carbonate, some part is getting precipitated as CaCO3. Okay, but still some part is there. This is in still in dissolved form. This is not getting precipitated. So that's why what what is happening is, from calcium, one form of calcium carbonate, sorry, magnesium carbonate, we are getting other form of magnesium carbonate. So we need to treat this also. So for that magnesium carbonate, we will need another mole of lime. So now we will get, yeah, magnesium hydroxide. So this is getting precipitated, and CaCO3. So this is also getting. So these two are getting precipitated. So here again 1 mole of lime is required. So that's why we are saying, to treat 1 mole of magnesium carbonate hardness, we need 2 moles of lime. Is it clear now? So from there it is coming. Okay, then we will see calcium non-carbonate hardness. So calcium, can you give an example of calcium non-carbonate? Any compound? Calcium non-carbonate hardness. So Ca, what can be the other part? CaCl2. It cannot be CaCl. It can be ClCa2. Okay, or CaSO4 or CaNO3 twice. Okay, anything can be there. So let's say CaSO4 I am taking. So CaSO4 will not react with lime, but with soda ash. So soda ash nothing but Na2CO3. Soda ash is Na2CO3. So we'll get again CaCO3. So this again will get precipitated plus Na2SO4. Okay, so we can say that for 1 mole of calcium non-carbonate hardness, we need 1 mole of soda ash. Right? So 1 mole of soda ash. Now one more question I will ask. Here calcium carbonate is getting precipitated. But what about this? This is Na2SO4. Do we need to treat this? Can we add 1 more mole of any other compound to treat this? Why we are not concerned about it? This is also in dissolved form. Why we are not concerned about this? Any idea? Why we are not adding something else and removing this? Because in the last thing, we treated this MgCO3, right? This was creating problem. So we added 1 more mole of lime and then treated it. But what about this Na2SO4? Why we are not concerned about it?
Sir, I think it is lowering the pH, so I don't need.
How it is lowering the pH?
Sir, I think sulfate is
No, 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 not related to pH.
sodium sulfate. Is,
Okay, but that is not the answer. That is not the pH thing. Why we are not? So here we are talking about hardness removal, right? We are removing hardness with the help of lime and soda.
It does
Na2,
not cause hardness.
yeah. So Na2SO4 will not cause any hardness. So we are not concerned about it now. So that's why we are letting it be in that form. Okay. So that's why no further calculations here. Right? Now coming to, yeah, Amit, that Le-Chatelier's principle, it is Le-Chatelier's principle or Langlier's principle? Are you talking about some Langlier scale or Le-Chatelier's principle? What is that actually? Because I think you are mixing up two concepts. That is about undersaturation and oversaturation. Okay. You please let me know what you're exactly talking about. I'm not getting your question here. Okay, so last thing, coming back to the, okay, so that is about the undersaturated and oversaturated thing that is not related to this lime soda. Okay, so let's not talk about it now. So again, last thing is the magnesium non-carbonate hardness. So that is MgSO4. So for to treat 1 mole of MgSO4, we need a mole of lime plus we need a mole of soda ash. Then only we will get CaCO3 as precipitate and MgOH twice as precipitate plus Na2SO4. So that is the overall. So we need 1 mole of lime and 1 mole of soda ash. So 1 mole of lime, 1 mole of soda ash. So are you able to understand how we are getting all these coefficients? So please make a note of this coefficient. Either you memorize it or you can derive with the help of these formulas. But I think it's very difficult to memorize these formulas, though this is nothing, just a displacement reaction. So you can also form it in the exam hall also, but it's better if you memorize this table because this one is very much important. So 1 0 0 1 2 0 1 1. So that's how you can memorize. Okay. So let us solve one problem now.
Sir,
So
I have one question.
yes,
Sir,
Mohan. Yeah.
sodium carbonate Na2CO3 is cause hardness.
How sodium carbonate will call hardness?
No, no, no. I am asking,
Ha.
does sodium carbonate cause hardness?
No, hardness, how it will cause? Hardness means multivalent
Because it is
cation.
polyvalent ion.
Yeah. Na2 is Na is
Ah,
monovalent, right? So it
ah,
won't
sorry,
cause
is
any hardness.
monovalent.
Yeah. It will not
Yes. Okay.
cause any hardness.
Okay.
Okay, now we will solve a problem. So this is actually question number 20. We will solve it directly here. I think no need to open that file. So in that question, uh, some impurities are given, okay, in the terms of various compounds. So we have CaCO3, we have MgCl2, we have MgHCO3 twice, we have MgSO4, then we have NaCl, we have Fe2O3, we have CaSO4, and we have SiO2. So these are the impurities we have in a system, SiO2. Their respective concentrations are also given to us. So concentration is 280, 138, 100, 80, 35, 55, 110, and 40. Okay, so all this concentration are. Now for the question, it says that what will be my lime dose if it is 86% pure, and what will be my soda ash dose if it is 98% pure for a water. Okay, so suppose the discharge Q is given as 50,000 liters per day. Okay, so I have to calculate these things. What will be my lime dose? What will be my soda ash dose for a discharge of 50,000 liters per day if the purity is 86% and 98% respectively? Okay, and these are the impurities given in the question. So now you please tell me how to approach this problem. What we have to do first. So I gave all that background, like how to get the number of moles for calcium carbonate hardness, calcium non-carbonate hardness, magnesium carbonate hardness, magnesium non-carbonate hardness. Based on that, we will have moles of lime and soda ash, right? So now you tell me how to approach this problem. What is the first thing we have to do? Please speak up anything, whatever comes to your mind. What is the first thing we have to do? Irrespective of whatever is asked in the question, what is the first thing we have to do? Forget the question. What is the first thing you have to do in these type of questions? Guys, please speak up. We have solved so many problems like this today. What is the first thing we do? No one? So what were we doing in all these problems? Suppose this problem. What were we doing the first thing? Jyoti, you are not audible, I think. Can you tell once more? Guys, please speak up. What is the first thing that we did in the
So total hardness.
total hardness? Okay, but what is the first thing? First thing, we have to convert everything in terms of milligram per liter as CaCO3, right? Because the base
Yes. Yes.
should be same. So please always remember, don't calculate anything based on the concentrations given in the question. So this concentration is given as per the ions or the compounds. So never calculate anything based on these concentrations. First, you have to convert everything as milligram per liter as CaCO3. So simply again, what we have to do? We are given 280 divided by the molecular weight of calcium carbonate. It is 50. Multiply. In the same form, we have to multiply. So it is 50. So it is 280. Then 138. What is the equivalent weight? It is around some 47.5 into 50. We will get 145.25. Then 100 by 73 into 50. We have to get 68.5. So this exercise we have to do every time whenever we get this kind of problem, because the base should be same when we are adding or subtracting anything. When we are calculating total hardness, alkalinity, lime concentration required, soda dose, whatever, first we have to convert in the same base as milligram per liter as CaCO3. Even for CaCO3 we are converting in terms of CaCO3, which will be the same thing. Okay, so I'm just writing it down, everything. You can calculate later maybe. So these are the milligram per liter. Now you tell me, okay, out of these impurities, now we need to calculate the lime dose and soda ash dose, right? So for lime and soda ash dose, we need to know what is the calcium carbonate, what is the magnesium carbonate hardness, what is the magnesium non-carbonate hardness, and what is the calcium non-carbonate hardness. So now see this table and tell me what is the concentration of calcium carbonate hardness. Tell me what, yeah.
280.
So it is 280. So calcium with carbonate, okay, there is no bicarbonate for calcium, so it is 280. What is my magnesium carbonate hardness?
68.5.
0.
No, 68.5. We have a bicarbonate of magnesium, right?
Yes. Yes, sir. Yes.
Okay, so It is 68.5. What is magnesium non-carbonate hardness? What is magnesium non-carbonate hardness?
That 68.5 plus,
No, just
sorry, 66.65 plus 145.
145.45.
yes, very correct. So 66.65 plus 145.25. And what is calcium non-carbonate hardness? What is calcium non-carbonate?
Sir, 280 plus
80.25.
80.25.
Why 280 you are adding?
Just
Oh, sorry.
80.25.
Only
Sir,
80.85.
only.
Only 80.85. So now we got all these concentrations. Okay. So now lime dose. First we will calculate the lime dose. So lime dose, what I said. So for each mole of calcium carbonate, we need 1 mole. So 1 into calcium carbonate hardness plus 2 into magnesium carbonate hardness plus 1 mole of magnesium non-carbonate hardness. This is what we know from the table. So for lime, 1 mole of calcium carbonate hardness, 2 mole of magnesium carbonate hardness, and 1 mole of magnesium non-carbonate hardness. So simply we can just add them. So we have found everything. So 1 into 280 plus 2 into 68.5 plus 1 into 66.65 plus 145.25. So we'll get it as 628.9. Okay. So can you tell me what will be the unit of this? What will be the unit of this? 620 of 0.8.9 what?
Sir, I think grams per mole.
How? See, we calculated everything in terms of milligram per liter as CaCO3, right? And then we are just simply adding them with the moles. So the unit will be milligram per liter as CaCO3, same unit, what we found. Okay, same unit. But now we have to find out the lime dose. So we have to find out the concentration in terms of lime. So now again, from milligram per liter as CaCO3, we have to convert back to the dose of lime. So what we will do, so this 60, so to convert from iron to milligram per CaCO3 means what we were doing, we were dividing it by equivalent weight into 50, the equivalent weight of CaCO3. But now here we will do it ulta, we will do it reverse. So we will divide it with 50, okay, and it multiply with equivalent weight of lime. So that is 37. So this is the equivalent weight of CaOH twice, and this is the equivalent weight of CaCO3. Just reverse you have to do. Okay, so now we will get it as 465.38 milligram per liter as CaOH twice. So in terms of CaCO3, now we will convert it back to lime. So since we want to find what is the lime dose, what is the dose in terms of CaCO3, if they are asking, we will stop it here. We will stop at this point. But since they are asking us lime dose, we will again go back and give it in terms of lime. So this was the dose. Now I said the discharge is around 50,000 liters per day. So what will be my daily lime requirement? So my daily lime requirement will be Q into the dose. So that is nothing but 50,000 liters per day into 465.38 milligram per liter, and milligram I will change into kg because this value will be too big. So 10 to the power 6 kg per milligram minus 6. So I will get it as 23.27 kg per day. So per day I need 23.27, but this is if it is 100% pure lime. But I said the purity is around 86%. So for 86% pure lime, daily required is equal to 23.27 by 0.86. I will get it as 27.26 kg. So that's how you have to do. So you understood now what is the difference here? Okay, very simple. You just have to remember the coefficients. You have to convert everything in terms of milligram per liter as CaCO3. Find out what are the calcium and magnesium carbonate and non-carbonate hardnesses simply. Okay, and then find out the lime dose with the help of these coefficients. So same thing we will do for soda ash also. Okay, soda ash also. So for soda ash, what is required? 1 mole of calcium non-carbonate hardness and 1 mole of magnesium non-carbonate hardness. So that's all. So okay, so magnesium non-carbonate hardness and calcium non-carbonate. These two you have to just add 1 mole. So for soda ash, it will be 1 into 80.85 plus 1 into 66.65 plus 145 plus 25. So it will be 292.8 milligram per liter as CaCO3. But then we will convert into in terms of soda ash. So 292.8 divided by 50 into soda ash equivalent weight is 53. Okay, so we will get it as 310.315 milligram per liter as soda ash or Na2CO3. So my daily requirement will be the flow rate 50,000 liters per day into 310.135 milligram per liter. Then purity is 98%, so 1 by 0.98 I will do into 10 to the power minus 6 kg per mg. So directly I can get it as 15.83 kg per day. Is it clear to all of you?
Yes, sir.
Okay, very simple. Okay, one more some kind of specific problem we will solve quickly just to give you some more context. Okay, otherwise these short questions are of no use, I think. I have solved basically all the time. See, so one chart I have already shown you. So directly in some questions this chart will be given. Okay, so before the zero level you can see the concentration of CO2 you have also given. Just forget it for now. You just see the right side of the zero part. Okay, we can say carbonate, sorry, we can say calcium and magnesium. Okay, then the HCO3 minus and Cl minus concentration, everything is given. So it says that uh, bar chart of a raw water sample which needs to be softened is given below. The desired level of hardness in the effluent is 100 milligram per liter as CaCO3. Okay, if lime and soda ash are assumed to be 100% pure, what is the dosage of lime required? So they are asking what is the dose of lime that is required in my system. Okay, so seeing this graph, quickly tell me what is the total hardness. So everything here is in terms of milligram per liter as CaCO3. Okay, so it is written here. All the values are in milligram per liter as CaCO3. So you don't have to change anything. You don't have to convert anything. Okay. So now tell me what is the total hardness here? Two 93.6, definitely. So calcium magnesium 293.6 is my total hardness. Now you tell me what is the alkalinity here. This is not asked in the question, but I am just asking. What is the alkali?
198.
198. So only bicarbonates are there, so 198. Now you tell me, okay, so so what is the desired level of hardness given? It is 100 milligram per liter as CaCO3. It is the desired. Okay, and we know the total hardness. So how much hardness I have to remove?
193.6.
So 193.6 I have to remove because total is 293.6. The effluent should have only 100. So in total I have to remove 193.6. Okay, 193.6. So now you tell me if 193.6 I have to remove, what is the form of hardness that is present in the system?
Sir, bicarbonate.
Bicarbonate. So you tell me, no, what is the form? Is it permanent or temporary?
Temporary.
Only temporary is there. So if only temporary is there, we need only lime, because for permanent only we need soda ash. So only lime is required. Okay. So now you tell me how many, suppose 193.6 milligram per liter of hardness I have to remove. So what is the amount of lime we will need? We know that 193.6 milligram per liter of hardness has to be removed as CaCO3. So what amount of lime is required?
Sir, 193.6 divided by 50 into 53.
Okay, so you are telling me the final, why 53? 53 is
Uh,
the 53 is the equivalent weight of soda ash, not lime.
oh, sorry. And
Lime is 37. It's 37.
37. Sorry,
Yeah,
37.
yeah. So that is the exact answer. So since we know for 1 mole of calcium carbonate hardness, we need 1 mole of lime. That's why we need only 193.6 milligram into 37 by 50 milligram per liter of lime. Is it clear to all of you? Others, it is clear, right? Huh. But here,
Yes, sir.
yeah, in this question, the only difference is, as I told you in one of, like during the stoichiometric, that for carbon dioxide also we need 1 mole of lime. Okay, to remove it, 1 mole of lime. So here the carbon dioxide concentration is given as 29.1. So along with 193.6, we will add this 21.9 also. So total hardness to be removed will be 193.6 plus 21.9. Is it clear? That is the only difference here. So if carbon dioxide is also given, then same amount of lime will be required for carbon dioxide also. So the final thing will be 193.6 plus 21.9, whatever you get, into 37 by 50. Right? So that's how you have to do. Now tell me, next question. What is the amount of soda ash will be required?
Sir, 193.6 divided by 50 into 53. The result
No,
is
no, no. One minute, one minute, one minute. See, understand, we need soda ash for calcium non-carbonate hardness or magnesium non-carbonate hardness, right? For this we want. So, is there any calcium non-carbonate hardness that I have to remove?
No, sir.
No, right?
Okay.
See, from the diagram, there is some calcium non-carbonate hardness also. Okay. So, from the diagram, can you tell me what is the calcium non-carbonate hardness present here? What is the calcium non-carbonate hardness present here? Don't see whatever statement is given in the question, just see the diagram.
Sir, calcium chloride and magnesium chloride.
Now, why magnesium? I am asking just calcium non-carbonate hardness. What is the value of
Okay, only
calcium?
calcium chloride.
Calcium chloride. How much is it? Tell me the value.
293.6
No.
or 238.
230 is the total calcium carbonate hardness. Total calcium hardness. Out of which HCO3 minus is the carbonate hardness and rest will be non-carbonate hardness, right? Just see here. This diagram you should learn to know, read very carefully. See, this is calcium, this is magnesium, this is HCO3 minus, this is Cl minus. This is 238, this is 293.6. This is 198, this is 293.6. Yes, Ronali, it is correct, 40. So how it is coming? See, this is the amount of bicarbonate. So this will only give the carbonate hardness. So up to here, this will be Ca carbonate. So CaCH, how much it is? It is 198. Right? Is it clear? So this one is the carbonate calcium hardness. Then CaNCH. How I will calculate CaNCH? Total carbonate hardness is how much? 238 minus the total calcium hardness is 238 minus the carbonate hardness of calcium is 198. So it will be 40. So this one will be calcium non-carbonate hardness. Now coming to magnesium carbonate. Is there any magnesium carbonate hardness?
No.
No, right? So it is 0. So it is 0. And what is my magnesium non-carbonate hardness?
293.6 minus
293.6.
238.
So 293.6 minus 238. That is my magnesium non-carbonate. Now in my question, they are saying that the total hardness is 293.6, but I need to remove only 193.6. Okay. So where is 193.6? It is coming somewhere here. So this is suppose 193.6. Oh, this is some multicolor. Okay, let it be. 193.6, it will be before 198, so I have marked here 193.6. Okay, so till this point, what do we have? So till this point we have only calcium carbonate hardness, so that's why we need 1 mole of lime. But do we have any calcium non-carbonate hardness till 193.6? No, right? So that's why we don't need any soda ash. Similarly, do we have any magnesium non-carbonate hardness till 193.6? We don't have. So that's why we don't need soda ash. So the soda ash requirement will be 0. Okay, so one thing is what the stoichiometric says. So it says that 1 mole of calcium non-carbonate hardness and 1 mole of magnesium non-carbonate hardness is required for the soda ash treatment. But in the question, they are asking I need to only treat 193.6. I won't care Whatever is after that, I won't care. I am not concerned. So I will not add any soda ash. Okay, is it fine to all of you?
Yes, sir.
Okay, I hope this was very interesting to all of you, because today I just thought of solving these problems. Okay, maybe, yeah, this problem you can try. Just keep a note of it. I will not take this question up today. Just take a screenshot of this. I am not telling you the answers also now. You try it out. If you are facing any difficulty, then you let me know. You can mail me. Okay. Thank you, ma'am. Thank you. So maybe if you want, because the next two lectures won't be having much numerical, I think. Yeah, I don't think many numericals is there. So maybe we can discuss these type of numericals, because I have four more numericals related to this. Okay, so you can see all these things are there. So I will stop here for today, because I think we had enough things for today. Okay, and if you are interested, we can take more questions like this in the upcoming class. And one more thing, please remember, on 10th April, our next class will be on 8th April. On 10th April, there will be an extra class, that is on Thursday. Uh, yeah, so on 10th April, Thursday, 5 to 7. Okay, it's a bit early. So 5 to 7, we will have one extra class, uh, so that I can take up more questions and any doubts like that. So if you have any particular type of, yeah, if you have any particular type, yes, Ashmina, you can speak up. You want to tell anything? Okay, I think it's by mistake. So if you have any particular type of questions that you want me to solve or take up, or any particular type of concept in the overall all the lectures, so starting from week 1 to week 11, by that time we will be finishing 11th lecture also. So in all these things, if you want me to take any kind of any particular kind of problem, please let me know beforehand. Okay, please let me know so that I can prepare some questions based on that. Right, any site related to BOD, COD, those problems, ASP, okay, trickling filter, whatever, or water treatment systems, disinfection, whatever is there. If you want me to solve any extra questions, you let me know before, or else whatever I find suitable, I will take those questions. So on Thursday, 10th April, 5 to 7. Is the time fine for everyone?
Sir, will that be the last interactive session?
No, after that, one more session we will have on 15th April. That will be for week 12 contents. Okay, so either what I can do, on 10th April, I can take a week 12 contents, and then for 15th April, I can have one extra session for all the questions, or on 10th April, I will take that extra session. So I don't want to break the schedule. I think 10th April will be better for the extra questions. So since you people are coming regularly, you please let me know in this week.
Sir, if you don't mind, can
Yeah.
we have this extra session on 17th, sir? If you don't mind, it's
No,
just my query.
actually, I don't have the liberty to take the session, because they are telling to take sessions before completed before 15th. So that is the problem. So that's why, and I think 10th will be a holiday also. It's Mahavir Jayanti. So I don't think it will be working. Like we have
Sir, it's
holiday.
working for us.
Okay. So 5 to 7, then, okay, you won't be able to join the class that day.
Sir, I'll try my best. It's a festival for me as well.
Oh, okay, okay. You are first. Maybe you can join for some time. Okay, and if you have any particular type of suggestions for that class, you can tell me. I will take up the class, record the session, and then you can see. That's also can be done. Okay, I will take up that
Okay,
question. I will solve those questions, and maybe you can see in your free time or whatever. Or else, if you are telling so much, then other dates, I don't think any feasible date is there, because I am also busy other days.
sir, 14th.
The 14th, again, it will be a holiday. Again, it will be a problem. And 15th again we have class. So back to back class will be a difficult for me, like continuously 2 days. Okay, so that's why I thought of. Okay, anyway, by this time you try to give the questions you want me to solve. Okay, so that I can prepare those questions and then discuss in the class, and maybe you can see the recorded lectures. Okay, so that's all from my side today.
Sir, I request you to do one revision kind of session, sir, because there is so much content that
Yeah,
we were.
but then revision in within 2 hours will also be difficult, right? So that's why I'm telling you any particular concepts or problem if you want, okay, you just ping me in the mail. Okay, you just tell me what are the different concepts you want, particularly some difficult concepts you want me to address. That thing we will solve, because going through everything will be very difficult within the 1.5 or 2 hours. And
Only the
people.
main topics that you feel as important from exam point of
See,
view.
for me, I can't suggest you. That's why I'm telling you, whatever you feel difficult. Okay, you might have faced some difficult problems, some assignment problems, or conceptually, if there any problem, you just ping me. So I will focus on those things more, and rest of the things maybe I can just skim through. Okay, maybe I will go through everything like in a very fast way, but the concepts which you are telling me or which you are indicating, I can take up in a elaborate manner,
Sir,
right?
14th is not a possibility.
14th I don't think so, because 15th is the last day, so one day before will be little tough. 14th is, I think, yeah, it's Monday
Monday.
also. Yeah, Mondays will be difficult because I have meetings on Monday. So it will be a
It's okay, sir. I'll go through the recorded sessions.
yeah. Or can we have it on 11th or 11th? 11th or 12th maybe. 11th or 12th is another option. I don't know if it is feasible. Is 11th or 12th fine for you?
I'll try, sir. I'm not sure
Yeah,
because.
that's fine. Okay, anyway, whatever is the final date, I will send you by mail. Okay, if you are able to join, please join.
Okay, sir.
Okay, okay, thanks. That's all from me, from my side.
Thank you.
Okay, bye. Good night.